This is Chapter 6, College Algebra 6.1. The name of this lesson is the parabola. And you've already been working with parabolas in your math career. And if you remember, if we have a graph here, a parabola is a graph that looks like that. Sometimes it looks like that. And today we're going to get into some that look like that and some that look like that. Okay, so that's what we're going to look at. If you look at the middle of page 526, they tell you where they get a parabola from, which is when you have two right circular cones with the vertices touching each other. We get what's called two cones, called the naps. And it's when you intersect one of those naps by a plane, you're going to get a parabola, a circle, or an ellipse. When you intersect both of those naps by a plane, you get a hyperbola, and we're going to look at all four of those in this chapter. And we're going to start off with the parabola. And in section 2.4, we started looking at parabolas where you found out that a quadratic function that looked like f of x equals ax squared plus bx plus c, where a is not equal to 0 because that would take away that there and make it a linear equation, so we don't want to do that. That is going to be the equation for a parabola. So one of the things I want to show you about a parabola is if we have an axis of symmetry, and let's use the y-axis here as our axis of symmetry, yellow dotted line there. And with our axis of symmetry, we have, and I am going to draw a parabola, and let's go ahead and make it right there. Put my vertex at the point 0, 2. So my vertex is right there. I also have a line that we're going to draw, and it is called the directrix. And I'll put it on here in red, and let's put it right here. Notice it is 3 units below the vertex. It doesn't matter where it is, it just depends on the particular problem on where that directrix is going to be. But if that is 3 units below the vertex, then we have another point that's 3 units above or inside the parabola that is called the focus. And we'll get into what all of these are and how they relate to each other later, but right now just be familiar with them and what they are. So the directrix is a line segment or a line that stays where it is. And we also have another point that's a fixed point that's called the focus, that's right here. And notice again, they're 3 units away, which means the vertex is going to be the halfway point or the midpoint between the focus and the directrix. Now this is an important piece of information, and my drawing isn't going to really help you see it very well, but it is the truth anyway. And that truth being, if we draw a line from our focus to any point on the parabola, that distance will always be the exact same distance from that point to the directrix. Okay? So that will always be the case. The distance from the focus to any point on the parabola will be the same as from that point on the parabola to the directrix. Okay, and the reason that mine is showing differently is because I put my parabola here with a distance 3 to the focus and 3 to the directrix, which means my parabola is not going to look like what it does there. It's actually going to, and I'll do this in black, look a little bit more like that. It's going to be flatter because of my focus and my directrix being where they are. So if I were to do this with yellow or red, now has changed. So the distance from here to here looks more accurate as far as being the same distance. So what happens is the distance from the vertex that the focus is and the directrix is has a relationship with how flat or how narrow the parabola is. So I just drew the parabola first and threw a focus and directrix in there just to explain it to you. Well, you can't just do that. You have to have a focus and directrix are directly related then to what your parabola looks like. So now the red line looks a little bit more like the distance from here to here is the same as the distance from here to here. Okay, so directrix and focus, two very important points there, as well as your vertex, which is right here. Okay, very important piece of information, middle of page 527 in blue, gives us the standard equation of a parabola with the vertex at the origin. So if I were to have a graph, obviously, that looked like this, and my parabola had as its vertex the origin, so it was going to look like that, and my directrix, obviously, because I said my directrix is outside of the parabola, my directrix is going to have to be somewhere down here, right? It can't be up here because that would be within the parabola. So what happens is if I have my parabola with a vertex at the origin and it goes up like this, which it will, my directrix is going to have to be down here, and that's why it says the directrix y equals negative p. That negative p is the distance from here, the origin, to where my directrix is. So it's the y distance, and it's going to be negative because it has to be below the x-axis because my vertex is on the origin. It also means that my focus then, and I'll do this in yellow, is going to have to be up there, which means that my y value of the focus has to be a positive number, right? So, and if my vertex of my parabola is at the origin, then my parabola, or my focus, which is going to be on the axis of symmetry, which is the y-axis, has to be left or right, 0. My x value is 0, and I went up p. Okay, notice I'm going to put the directrix segment there. This point is at 0, negative p. The directrix is a line, so we're not going to even call it, we're not going to say the 0 portion of it. We'll just say that y equals negative p, because it's a line. So y equals negative p is my equation for my directrix. And notice I have a p here and a p here. So the p represents the distance from the origin to my focus, my origin to my directrix, and the origin, which is my vertex. So this distance from here to here is going to be the same as the distance from here to here. It's just one went in a positive way, one went in a negative way. And this is, again, the vertex is the midpoint. If I were to make a little bit of change, so that being the case, with a parabola that is this shape, this is the formula for it. This is the standard equation for a formula with a vertex at 0, 0, the directrix at y equals negative p. So the focus is at 0, p, and the y-axis is the axis of symmetry, which we just went over here. So this formula right here is a very important formula to remember. Okay, the next formula, which is right here, the difference between it and what we just did, let's move this up a little bit. And it says, let me draw another graph, it says that the standard equation of a parabola with a vertex at 0, 0 and a directrix at x equals negative p. Okay, so this one over here on the left was for 1y equals negative p. Now we're going x equals negative p, which means our directrix is going to be over here this time. And what else does it say? The focus is at p0. So the focus is going to be the same distance from here to here, because that's p. It says the focus is going to be at p0. So we're going to go to the right p and not up or down at all. So that's going to be the focus. So what has happened is my directrix has changed to a vertical line. My focus has changed there, which means my parabola is going to have to go like this. Okay, so notice it went sideways. And I can tell it went sideways because if my directrix is x equals negative p, that means it's going to be over here in a vertical line, which means my parabola is this way. If my y is negative p, that means I've got a horizontal line and my parabola is this way. So that's why we've got two different equations here, is because one is for I'm not sure what they're even going to call it, an up and down parabola like we have here, or a sideways parabola. So I don't know if there's a name for how that works, by switching it from up and down to sideways, but that's what we've got there, are those two equations. So let's look at example 1, bottom of page 527, and they give us an equation. First thing that we have to do when we're looking at this equation is find out which of these two formulas we're going to be dealing with. Well, this has an x squared on it, so that means we're automatically going to use this formula here. If it had a y squared, we'd be using this formula. So we're going to use this formula here, which means we have to take this equation and set it up to look like that. Okay, so what we're going to have to do is we're going to have to isolate that x squared, so it's x squared equals something rather than what we've got here. Alright, so let's go ahead and do that. First thing I'm going to do is I'm just going to switch things around. I'm going to put the right hand side of the equation on the left and make that equal to y, just so I have my x squared on that side. And then I'm just going to multiply both sides by negative 12. And then I get x squared equals negative 12y. Now, at this point, I don't quite have my problem set up this way because there's a 4 there and I've got a negative 12. But I can factor out a 4 and be left with a negative 3 right there, right? So there's my negative 4. So what I have here is my x squared, I've got my 4, and my p is going to be negative 3, and then I have my y. Okay, so that's in the format I want. So what does this information mean? Well, according to what we have up here, the parabola has a vertex of 0, 0, and the directrix is y equals negative p. Okay, so my directrix in them, this is what it's asking me to find, is the focus and directrix. So my directrix is y equals negative p. Well, so y equals negative p, well there's my p. So my directrix is going to be a negative, and my p is negative 3, which gives me my directrix being y equals 3. So actually what I've got is I've got a directrix that is at 3. 1, 2, 3. So I've got this as my directrix. It's also asking me to find the focus. And the focus is y equals, let's see, the focus is 0p. So what I'm going to do is I'm going to go, my focus is at 0p, which means I'm going to have a focus of 0. And what is my p-value? My p-value is negative 3. That's what I got right there, negative 3 for my p. So 0, negative 3 is my p-value. 1, 2, 3. So that means if my focus is down here, and my directrix is up here, my vertex is at the origin, and because my parabola cannot cross my directrix by going up like this, it's going to have to be like this, going down, so that my focus is right there inside the parabola and my directrix is outside. So that's how you can determine whether it opens up or down. Plus another way is you've got the negative sign right here. Okay, so anyway, that was finding the focus and the directrix. It didn't ask you to graph it. Oh, I guess it did ask you to graph it, but normally that's just the way you find the directrix and the focus. Now, if it asked you, if it gave you an equation here and had the y squared and the x not squared, you would have used this part of the formula right here, and you would have found that x is negative p and the focus was p0. So not much difference there, but just be aware of that when you're solving these.